Hi everyone. In this video we're actually going to be adding and subtracting rational functions. Now, before we actually go ahead and actually start adding and subtracting, what we're going to look at are the steps. The first step is the most important step. You always need to factor out your denominator when you're able to. Then after that, you want to be able to find your LCD. Now, throughout the video, I'm always going to ask for numbers, variables, and parentheses. And that's because when you're trying to find the LCD, you always want to look at the numbers, the variables, as well as the parentheses. And when it comes to variables and parentheses, you always have to take the highest exponent. And then lastly, when we're actually adding and subtracting, you want to multiply the numerator from what's missing in the denominator that your LCD has. Okay, so these are the most important steps that you want to be able to know in order to actually add or subtract rational expressions. So we're going to go ahead and get started. So we're going to take a look at this example. The first thing you'll notice is we can't add these two rational expressions because they don't have the same LCD. So we have to go about finding this LCD. So what I'm going to do is I'm always going to write my LCD here. And the reason is you need to find your LCD before you can actually do anything. So when it comes to 18 and 27, you want to find a number that 18 and 27 both go into, your least common multiple. Now you can list all the multiples of 18 and multiples of 27 and see which one comes first. But an easier way is take 18, take 27 to the side, and I want you to create this L shape. What you're going to do is you're going to take out a number that 18 and 27 have in common. For example, 9. Then you're going to ask yourself, well, how many times does 9 go into 18? Twice. How many times does 9 go into 27? 3 times. Then you're going to ask yourself, well, can you take anything else out of 2 and 3? Your answer should be no. So then you're going to actually go ahead and multiply this L shape. So 3 times 2, 6, 6 times 9 is 54. So that means that your LCD for 18 and 27 should be 54. So you first do numbers and then you're going to work with variables. Well, your LCD is pretty much everything your denominator has. So you notice that it has an x. But that's why you want to memorize x to the highest power, which your highest power is 3, so this is going to be a cubed. Then it has a y, so you're going to put a y, but y to what power? The highest one, which is a 3. So then your next step is, well, once you find your LCD, what you want to do is you want to be able to multiply the top and the bottom by whatever is missing from here that your LCD does have. So you first want to look at your numbers. Well, your bottom should be a 54, but it's an 18. So 18 times what gives you 54? 18 times 3. So you have to multiply top and bottom by 3, because 18 times 2 will give you 54. Now look at your variables. Well, there's an x cubed here. What about here? Is there an x cubed? Since they both have the same x cubed, we don't need to multiply top and bottom by x cubed because it already has it. Then you're going to look at y. Well, there's a y here, but there's a y cubed here. So how many y's are you missing? You're missing y squared, so you're going to multiply by y squared. Okay? So then you're going to look at your next rational expression. You have a 27, but it's 54, so what am I missing? I'm missing a times 2. Because 2 times 27 gives you 54. Look at your variables, x squared, but there's an x cubed. So that means I'm missing an x. How many of them? 1x. Y cubed, so I don't have to multiply by y. Now once you find your LCD, the shortcut is don't actually work on the bottom because you know your LCD is going to be the same exact thing. All you want to focus on is the top. So you're going to multiply 3y squared times 1, which gives you 3y squared, and then 5 times 2x, which gives you positive 10x. Now before I actually write my LCD on the bottom, I'm going to simplify this. You always want x's in the front. So I'm going to change this to 10x plus 3y squared. Now since I can't do anything else to this, I can't factor this, I can't work anything out, so what I'm going to do is I'm going to put this over my LCD. And that would be my final answer. Okay? So when you're able to actually simplify the numerator, you're going to go ahead and do that. But since in this case you can't do anything, you're just going to leave it just like that. So now we're going to look at a different example. 1 over x squared minus x plus 1 over x. So your first step, anytime it comes to adding, subtracting rational expressions, is you have to simplify your denominator. You have to factor it out. So you'll notice there's an x squared here and an x. So that means I can take out an x. So I'm going to take out an x and I'm going to be left with x minus 1. Now I know I factored this correctly because if I do x times x, I get x squared. X times 1 gives me negative x, so I'm perfect. This I can't do anything with it, so I'm going to leave it just like that. Now remember, your goal is to find an LCD in order to add or subtract these. So when it comes to LCDs, you want to look at numbers. And what I mean by numbers, are there any numbers on the outside other than 1? There's no numbers. So then I'm going to look at variables. Are there any random variables? Well, there's an x by itself and x by itself here, so I'm going to put an x here. X to what power? They're both being raised to the first power, so that's why it's just going to be x. Then ask yourself, are there any parentheses? You'll notice that there is a parenthesis, x minus 1. So that has to belong to my LCD. So my LCD is going to be x minus 1. Now my next step is, well, I want to multiply my numerator by whatever my denominator is missing that my LCD has. It has an x. It has x minus 1, x minus 1. So sometimes your denominator is going to be your LCD, which is fine because you don't have to multiply anything to the top. So you can move on to the next one. It has an x, but what's it missing? X minus 1. So you're going to multiply bottom as well as your top by that x minus 1. Now remember, we're not going to work out the bottom because that's just your LCD. So just focus on the top. I didn't multiply anything to 1, so I'm going to leave it as that. Plus 1 times that just gives you x minus 1. Combine like terms. 1's cancel out. I'm just left with x. I can't really factor out x because it's one term, so then put it over your LCD. Then this happens. If you'll notice, you have an x on top and an x on the bottom. In the case that you're able to cancel this out, you're going to cancel it out because the top looks exactly like the bottom. So that means you're going to be left with 1 over x minus 1. And this is your final answer. Now when it comes to this problem, you want to be careful, because sometimes we end up crossing this out and just leaving x minus 1, but we got to remember x minus 1's on the bottom, so it has to stay on the bottom. So anytime you cancel something out and there's nothing left on top, make sure you put a 1. Okay? So we're going to do a couple more examples. So that we'll have this one. First step, like always, factor it out. Can you factor out x minus 2? You can't because it's just simplified already. What about x squared plus 4x minus 12? Well, you can simplify this to become x plus 6, x minus 2. So then you can go ahead and find your LCD. Remember, LCD is whatever they have in common. Sorry, whatever they have, whatever your denominator has. So if you'll notice, it has an x minus 2. And sometimes we're going to end up putting x minus 2 twice because you see that it has it here and here. That's not true. What you always want to do is you want to take out the highest x minus 2. If you notice, this is raised to the first power, and this is being raised to the first power. So that's why you only take out one x minus 2. And then the last one is, it has an x plus 6. So your LCD is going to be an x minus 2 and an x plus 6. So your next step is, well, what do we have to multiply this one by? What's it missing? Well, it has an x minus 2, but what doesn't it have? It doesn't have an x plus 6. So you're going to go ahead and multiply this by x plus 6. What about this one? Is it missing anything? No, because it has both of them. It has the x plus 6 and it has x minus 2, so you're going to leave it exactly alone. So your next step, work out the tops. But in this case, you're going to have to end up distributing everything out, which is like foiling. Now, the one thing I want you to be careful with is anytime you see that there's a negative sign in the middle, make sure you put the minus sign with a huge parentheses, because you have to end up distributing this negative. Anytime there's a minus sign, you have to distribute it to everything on the top. So that's why I want to put negative with parentheses. So now I'm going to work this out. Gives me x squared minus 6 no, I'm sorry. X times x, x squared, x times negative 1 minus x, 6 times x plus 6x minus 6. Distribute the negative, negative x squared minus 4x plus 4. Distribute the negative out to everything. Combine like terms. Well, notice that this x squared and this x squared cancels out. Then I'll see negative x plus 6x, that'll give me 5x minus 6, minus 4x plus 4. Then this can combine with that, which gives you x, negative 6 with the 4 gives you minus 2. Then you're going to ask yourself, well, can I simplify this? Can I factor this out? Can't do anything with this, so then I'm just going to put it over my LCD. X minus 2, x plus 6. So then you're going to ask yourself, well, can I cancel anything out? Does anything look the same? It actually does. The top and the bottom look identical. So when that happens, cross them out. So then you're left with, remember, there's nothing left on top, so you're left with a 1 over x plus 6, and that's your final answer. Okay? So you just gotta be careful when you're actually folding everything out. Make sure you distribute everything. X times x is x squared, x times 1 is -1, 6 times x is 6x, 6 times -1 is -6. Then you want to be able to combine like terms. But, once again, anytime your problem has a negative, make sure you distribute that negative, like we did here. Okay? Alright, this is going to be our last one. X plus 2 over x minus 6 minus that entire equation. First thing I'll notice that there's a negative. So what am I going to do with that negative? I'm going to distribute it afterwards. But first, I'm going to factor it out. I factor it out to give me x minus 6, x plus 4. So then I'm going to go ahead and find my LCD. My LCD has an x minus 6, but how many of them? 1, because the highest exponent for both of them is to the first power. Anything else? X plus 4. So then you can go ahead and multiply whatever's missing to either one of these expressions. So for this one, I don't have an x plus 4, so I have to multiply my top by x plus 4. Is this missing anything? No, it has everything. So once it has LCD, I'm going to leave it exactly alone. So then I'm going to take this side, work it out. X plus 4 times x plus 2 minus big parentheses because we're going to end up distributing that negative. Plus 5x plus 14. So then once you have that, you want to actually work everything out. Distribute everything. FOIL this out. X times x is x squared. X times 2 is 2x. 4 times x is plus 4x. 4 times 2 is 8. And then you can combine like terms again. X squared plus 6x plus 8. Then distribute this negative. Negative x squared minus 5x minus 14. Then bring it down. Negative x squared minus 5x minus 14. Combine like terms. This cancels out. Gives you just x. Combine like terms again. 8 negative 14 gives you minus 6. So then you're going to try to work out x minus 6, but you can't do anything, so you're going to put it over your LCD. X minus 6, x plus 4, but you'll notice that something's going to cancel out. This ends up canceling out, which is going to leave you with 1 over x plus 4. Now, not everything's going to always cancel out, so you have to be careful. Everything's not always going to cancel out. So when you're able to cancel out, you actually want to cancel it out. But the one thing that you want to be careful with is you have to be careful with distributing. If you make one little mistake along the process, you're going to end up getting the wrong answer. So when you're actually folding everything out, distributing a negative, combining like terms, just be careful. Alright, hope this video helped. Thanks for watching.